Assalamu alaikum students. I hope you people are doing good at your homes. Last time we couldn't attend a class as I was not feeling well due to my certain health conditions. I was unable to connect with you people. So I'm back with another lecture. Hope you people are practicing the moment we are I can say discussing the things. I make you people clear what actually we discussed it actually last time, Dalton's atomic theory. I told you people that the basic nitty-gritty of this Dalton's atomic theory, I mean to say the bottom line of this Dalton's atomic theory is that it actually revolves around the atom. I told you people that it was actually the earlier scientists, I can say Democritus and Leo Cups, and Indian philosophers as well, like Maharishi Kanad. They also gave this atomic concept, and it's actually the atom. Every single theory, rather that's Dalton's atomic theory. Whether we have discussed certain laws, and that laws were actually the laws of chemical combinations, like law of conservation of mass, law of definite proportions. All every single law, I can say every single theory is actually revolving around this Dalton's atomic theory. Actually, this atom is a concept. Why this have been included in the class 9th, atoms and molecules, so that you people understand what actually this atom and a molecule is. So I'm trying my level best. I can say I'm giving my heart out to make you people understand the basic concept of this atom. So I told you people in the last video lecture that around 25% chemistry around this Dalton's atomic theory. So this is a very important topic as far as chemistry is concerned. So last time we were talking about the fourth postulate of the Dalton's atomic theory. Let me recapitulate what we discussed. Regarding this fourth postulate, I told you people that atoms of a given element are identical in respects, I mean, say in all respects, having the same mass, size, and the chemical element. For example, this is one. Let's take the example. Presently, we have 118 elements. Now, let's take the example of any one of the elements. For example, this is potassium. The moment I'm quoting the example of potassium, this potassium is actually an element. Firstly, you people must remember that what actually this element is. I have given almost 5 lectures as far as element is concerned. Let me recapitulate what this element is. Element is actually a substance made up of single type of atoms, or I can say only one kind of atoms. So you must remember that element is actually a substance made up of single type of atoms. So this I can say this potassium is wholly or solely made up of single type of atom. That means this potassium is wholly or solely made up of the atoms of potassium. So my dear students, I told you people that atoms of given element, this is a given element, for example, it's a given element potassium, are identical in all respects, having the same mass, size, and the chemical properties. For example, the moment I will break this potassium, mark my words, students, mark my words, have concentration towards me. The moment I'm telling you people that this potassium is an element, the moment I will break this element, it will get changed into small indivisible particles. You must remember that, students. I told you people that those smallest indivisible particles, my dear students, are called as atoms. So this potassium actually comprises of millions and trillions of atoms, my dear students. So the atoms of same element, for example, all the atoms of a given element, the moment I will break this potassium, it will get broken down into I can say indivisible tiny particles, indestructible ultimate particles, and we call those I can say indestructible or tiny or indivisible particles as atoms. And every single, mark my words, student, this is very important topic here, mark my words, students, atoms of same elements, I mean to say atoms of a given element are identical in all respects. These atoms, the moment I broke this potassium, every single element of this, every single I can say atom of this potassium is identical in all respects. I mean say having same mass, they are having same size, illa not yet. Having the same mass, my dear students, same size, and show the similar chemical properties. Mark my words, students, and jot it down with me. I'm telling you people that the moment I broke this potassium, it gets broken down into the, I can say, millions and trillions of the potassium atoms, and every single atom of this potassium is having the same mass, having the same size, and show similar chemical properties. That's what Dalton actually said in his fourth postulate. Dalton said that atoms of elements, I can say this is the same, I can say particular element, I mean to say particular element, my dear students. Atoms of element, that's particular element, are identical in size, in shape, in mass, and other properties. Other properties means this shows similar chemical properties, my dear students. Chemical properties. So, my dear students, the fourth postulate of the Dalton's atomic theory is that atoms of an element. I told you people that atoms of the potassium, I give the example. You can take example of any one of the elements, my dear students. So, I told you people that atoms of an element are identical. They are identical in size, they are identical in shape, they are identical in mass and other chemical properties. That means they show the similar chemical behavior. That means they show the similar chemical properties, my dear students. So the fourth postulate of the Dalton's atomic theory is that all the atoms of a given element are identical in all respects, irrespective of the size. I mean say in all respects having the same mass, having the same size, and the same chemical properties. So this was the fourth postulate of the Dalton's atomic theory. So Dalton's atomic theory, the fourth postulate tells us that all the atoms of a given element are identical the moment we broke this element, particular element, in small indivisible tiny particles, and we call those tiny particles as atoms. The moment I can say we broke this, I can say this particular element in small indivisible particles, every single indivisible particle, mark my words students, every single indivisible particle, every single tiny particle, every single indestructible ultimate particle is having the same mass, having the same size and same chemical properties. That means every single atom of this particular element will show same chemical behavior. So this was the fourth postulate of the Dalton's atomic theory, my dear students. Let's discuss another postulate as postulate number 5, my dear students. My dear students, now the fifth postulate. Fifth postulate of Dalton. We are discussing actually, my dear students, John Dalton's atomic theory. Mark my words, students, that he proposed in 1808 after the laws of chemical combination. So the fifth postulate of this Dalton's atomic theory, my dear students, is that atoms of different elements, let's discuss first this point, atoms of different elements. For example, let's take another example. For example, this is zinc, this is iron, Fe. Fe is a symbol of iron, and Zn, zinc, is a symbol of zinc. Zn is a symbol of zinc, Fe is a symbol of iron. This is zinc, mark my words students, this is zinc, this is iron. So these are actually the two different elements. Zinc is one element and iron is another element, my dear students. That's why I told you people, atoms of different elements. They are actually the different elements. The moment we will broke these two elements, every single, that means zinc and the iron will get changed into, I can say, different atoms. For example, zinc will get broken down into atoms of zinc, and iron will simply broken down into, I can say, atoms of iron. That's why I told you people, they are actually the two different elements, zinc and iron. The moment we will broke these two elements, zinc will get broken down into zinc atoms and iron will get broken down into iron atoms. So atoms of different elements, these are the, I can say, different elements, they will give different atoms when we will broke them. So atoms of different elements are different in their properties. For example, what is Dalton actually telling us? He's telling us that atoms of different elements, these are the two different elements, are different in their properties, means that they will show different properties. That means they will not be identical in size, identical in size, identical in mass, identical in shape, identical in chemical properties. Jot it down, my dear students. It's a very important topic. So the fifth postulate, what fifth postulate is telling us? Fifth postulate is telling us that atoms of different elements, these are the two different, one is zinc, another is iron, are different in their properties, means that the moment we'll break these two atoms, I can say they will get changed into small indivisible particles, and those small indivisible particles are called as atoms, and they will give different atoms, I can say, when we will break them. The moment we will break them, and the atoms of zinc will have the same size, same mass, same shape, same chemical properties, but the atoms of zinc will not match with the atoms of, I can say, the iron. The iron atoms will show different behavior than that of the zinc. Or same is the case with the zinc atoms. Zinc atoms will show different chemical behavior and they will show different properties than that of the iron. That's why I'm telling you, my dear student, that atoms of different elements are different in their properties, means zinc will show its properties and iron will show its properties. So they both will show different properties. That's why I told you people that the atoms of different elements are different in their properties, means they differ in size, they differ in mass, they differ in shape, they differ in chemical properties. That means atoms of the zinc will not show the properties of the iron atoms, and the properties of the iron atoms will not show the properties of the zinc atoms. So that's why I told you people that they will show the different chemical behavior first, and they will show different size, and they will I can say show different mass. That means mass variation will be found as far as zinc and iron is concerned, and the atoms of the zinc will have the one size, and atoms of the iron will have another size. That's why the atoms of different elements are different in properties. That means every single different elements are actually different in their properties. They are different in their mass, different. So they will show different, I can say, atoms of different elements will show the different properties. Like I gave you the example of zinc and iron. As far as the zinc is concerned, zinc, the moment we will break the zinc, and it will get changed into atoms of zinc, and the moment we will break this iron, it will get changed into atoms of iron, and these two, I can say, elements will show different chemical behavior. They will also show they will differ in size, they will differ in mass, and they will also differ in size as well. So the fifth postulate of Dalton's atomic theory is atoms of different elements are different and have different mass, size, and chemical properties. So my dear students, you must remember that the sixth postulate, which Dalton is actually trying to make us understand, that atoms of different elements like atoms of zinc and iron, I can say, have different mass, and they have different size, and they have different, I can say they show different chemical properties. That means they show the different chemical behavior as far as zinc and iron atoms are concerned. My dear students, this was actually we discussed the two postulate number 4 and postulate number 6. Hope you people enjoyed this video, and in next video lecture we are going to discuss some more postulates regarding this Dalton's atomic theory to make you people understand what actually this atom is. Till then, stay safe and stay at your homes. Allah bless you all. Thank you for watching this.